A breakthrough for scientists after they had a 20-minute conversation with a humpback whale.
Over the next 5 years, our team of AI specialists, roboticists, aim to use the most cutting-edge technologies to make contact with another species and hopefully communicate back.
You've probably seen the headlines. AI translates what whales are saying. Scientists decoded crow language. We can finally talk to animals. These clips spread fast, and they all point to the same idea, that artificial intelligence has cracked something humans have wondered about for thousands of years. And what scientists have actually found is more interesting than the viral claims. The claim going viral. Scroll through YouTube Shorts, TikTok, or even mainstream news feeds, and you'll see the same story repeated in different forms. AI is translating whale songs. AI has decoded the language of crows. Dolphins are having full conversations, and we can now listen in. The message is usually the same. Machines have unlocked animal language, and the barrier between species is finally coming down. The reason these claims spread so quickly is simple. Artificial intelligence is one of the most talked about technologies of the decade. Animal intelligence has fascinated people for generations. Put those two things together, add a dramatic headline, and you have content that almost anyone will click on. There's also something deeply appealing about the idea itself. The thought that we might finally cross the barrier between humans and other species, that we might one day understand what a whale or a crow is actually thinking, taps into a curiosity that goes back as far as recorded history. But there's a problem. Most of these viral videos skip over what the research actually says.
This is his button board.
They take early-stage studies, remove the scientific caveats, and present cautious findings as finished breakthroughs.
If the computer encodes
Pretty much like that.
and calculations don't give it away,
We're trying to tell
Kenny Zhu is a professor of computer science, so it might come as a shock to learn what he's being paid to research.
people have always tried to understand what animals are talking about.
A single press release about an interesting pattern becomes, within a few days, a confident statement that animal language has been cracked. Why the headlines feel so convincing? Part of what makes these claims so persuasive is that they contain a grain of truth. Scientists really are using AI to study how animals communicate. Research groups are analyzing whale sounds. Ornithologists are studying crow vocalizations. Marine biologists are looking at dolphin signals. These projects are real, ongoing, and carried out by serious institutions around the world. The problem is what happens to these studies once they leave the scientific world. A paper about detecting patterns in sperm whale clicks becomes AI is translating whales. A study about classifying bird calls becomes scientists decoded crow language. The careful wording researchers use, words like may indicate, suggests, patterns consistent with, tends to get stripped away in favor of something bolder and simpler. By the time the story reaches a social media feed, the research has been flattened into something much more dramatic than what the scientists actually claimed. And once that simplified version spreads, it becomes hard to undo. Each new viral clip builds on the last, and the gap between headline and research keeps widening. Before we go deeper into the research itself, if this kind of investigation, separating viral claims from real evidence, is the sort of thing you'd like to see more of, consider subscribing. New breakdowns go up every week. What AI is actually doing in animal research. To understand where the viral claims go wrong, it helps to understand what AI is really being used for in this field. The kind of artificial intelligence used in animal communication research is built around pattern recognition. These systems are very good at taking huge amounts of sound data and finding repeating structures inside it. That might mean identifying sounds that occur in similar sequences. It might mean grouping calls that appear in specific situations, Like when food is nearby or when a predator is present, it might mean detecting subtle variations that a human ear would miss across thousands of hours of recordings, tiny differences in pitch, rhythm, or timing that might carry information. This is genuinely useful. Before AI, researchers had to listen through recordings by hand, which limited how much data they could work with. Now, they can process years of audio in a fraction of the time. That opens up questions that simply couldn't be asked before. But here's the key point. Finding a pattern is not the same as understanding meaning. AI can tell researchers that a particular click sequence appears often in a certain context. It cannot tell them what that sequence means to the animal making it. Those are two very different things, and confusing them is where most of the viral content goes wrong. There's another reason this distinction matters, and it comes into focus when you compare animal communication research to human translation software. Google Translate works because decades of dictionaries, grammar books, and parallel texts have given machines something to learn from. Sentences in one language are paired with sentences in another. For animal communication, there is no such dictionary. There is no Rosetta Stone. Researchers are trying to reverse engineer a system from the inside without knowing what most of the pieces refer to, and without being certain that the pieces even map onto human concepts at all. Project CD and the sperm whale. Research. One of the most talked about projects in this space is Project CETI, short for the Cetacean Translation Initiative. It's an international research effort that uses machine learning to study sperm whale communication. The project has received significant funding and media attention, and it's often cited in viral videos as proof that we're close to translating whales. What the project is actually doing is more measured. Sperm whales communicate using short bursts of clicks called codas. Different groups of whales use different coda patterns, almost like regional accents. Project CETI is using AI to collect and analyze these codas at a scale that wasn't possible before, looking for underlying structure in how the clicks are organized. To gather the data, researchers use underwater microphones, tags attached to whales, and other tools to record enormous volumes of sound over long periods of time. Early findings have shown that sperm whale codas appear to have more internal structure than previously understood. Researchers have identified features like rhythm, tempo, and variation that combine in ways that look, at least on the surface, somewhat similar to features found in human language. That's a genuinely interesting result, and it's one reason the project has drawn so much attention. But the researchers themselves have been careful about what this means. A pattern that looks like it could carry information is not the same as a confirmed unit of meaning. And even if whale codas do carry information, which seems likely, that still leaves the much harder question of what the information actually is. A coda with a particular rhythm might correspond to something about identity, group membership, or social context. Or it might be something humans don't have a close equivalent for. The data doesn't settle the question. Project CETI is expanding what we know about the complexity of sperm whale communication. It is not translating whale conversations, and the researchers have never claimed to. Crows, songbirds, and the study of bird calls. Whales aren't the only animals getting attention. Birds, especially crows and other members of the corvid family, are another major focus for this kind of research. Crows are studied heavily because they're highly intelligent, socially complex, and produce a wide range of vocalizations. They also live near humans in many parts of the world, which makes them easier to observe and record consistently over long periods. AI tools are being used to classify crow calls, match them to behaviors, and look for patterns across populations. Similar work is being done with songbirds, parrots, and other vocal species. Some of this research has found that certain calls are linked to specific situations: warning calls for predators, food-related calls, contact calls between family members. In some cases, birds appear to use slightly different calls for different kinds of threats, which suggests a level of specificity that surprised earlier researchers. These findings can sound impressive, and in many ways they are. A crow that uses one call for a hawk and another for a human is doing something cognitively sophisticated. But identifying that a sound is linked to a context is closer to recognizing a traffic signal than reading a sentence. A red light reliably means stop, but a red light doesn't have grammar. It doesn't combine with other signals to form new meanings. The same limit applies to most of the animal calls researchers have mapped so far. The researchers working with birds generally describe their work as studying communication systems, not translating languages. The biggest misconception. This brings us to the single biggest gap between the viral narrative and the real science. The viral claim is that AI understands animal language. The reality is that AI is helping scientists study animal communication. That word change matters. Communication is broad. It includes any signal one animal uses to affect the behavior of another. A warning cry, a mating display, a chemical trail, a physical posture. All of these are communication. Language, in the technical sense used by linguists, is something much more specific. It involves a structured system of symbols that can be recombined to refer to things beyond the immediate situation, including things that are abstract or hypothetical. The ability to talk about yesterday, or about a place you aren't in, or about something that has never happened, is part of what sets human language apart. Whether any animal communication system qualifies as language in that strict sense is still an open scientific question. Most researchers agree that human language has features, such as open-ended grammar and reference to things that aren't present that haven't been clearly demonstrated in other species. That doesn't mean animal communication is simple. It can be remarkably rich, and in some cases it shows unexpected levels of structure. But it may not be language in the way humans use the word, and that distinction matters for understanding what AI can actually do. What scientists actually say. If you read statements from the researchers working in this field, a consistent picture emerges. They describe animal communication as complex, layered, and often underestimated. They describe AI as a powerful new tool for studying it. And they describe the idea of fully translating animal thoughts as something that remains, at best, a long-term goal, and possibly not achievable at all. Many researchers are careful to point out that some of what animals communicate may not map neatly onto human concepts. A whale's click pattern might carry information that simply doesn't correspond to anything in human experience. Even if AI could detect it perfectly, translating it into words we understand might not be possible because the concepts may not line up. A species that lives underwater, navigates by sound, and spends much of its life in deep darkness may have something to communicate that has no clean equivalent in a human vocabulary. This doesn't make the work less interesting. Researchers are exploring forms of communication that may follow completely different rules from anything humans have experienced. That's a much deeper and more unusual question than simply teaching a computer to translate. Why the real science is more interesting. The real findings are, if anything, stranger than the viral version. Sperm whales appear to have structured communication systems that vary by group, almost like cultural differences passed down over generations. Crows can adjust their calls based on specific threats, and some studies suggest they can recognize and remember individual human faces, which may influence the calls they produce. Some songbirds show regional variations that change over time, similar in pattern to human dialects. Researchers are finding that animal communication, even without being language in the human sense, is richer and more varied than science once assumed. AI is making it possible to study this at a depth that wasn't feasible before. It lets researchers analyze data sets so large that a team of humans could never listen through them in a lifetime. It catches subtle patterns that individual observers might overlook. It's a tool that's genuinely changing the field, even if it isn't doing what the viral headlines claim. The actual story is about careful, slow, incremental progress. It's about researchers working for years to gather data, test ideas, and rule out easier explanations before making any strong claims. It's not as flashy as "we can talk to whales now," but it's a truer reflection of how real science works. Conclusion: scientists are not translating animal language. They are studying animal communication with powerful new tools, and that work is producing genuinely interesting results. AI has expanded what's possible in this field, but it hasn't replaced the hard work of figuring out what, if anything, animal signals actually mean. The viral version of this story gets a few things right. AI is involved. Animal communication is more complex than many people assume. Researchers are making progress. But the idea that we now understand what whales, crows, or dolphins are saying goes well beyond what the evidence supports. No whale sentences have been decoded. No crow vocabulary has been confirmed. No species has had its communication fully understood. The field is moving forward, but it's moving at the pace of actual research, not internet headlines. If there's one thing worth remembering, it's this: the real science is cautious, patient, and full of open questions. And that's not a weakness. It's how careful research actually works. The viral claims promise a finished breakthrough. The real story is an ongoing investigation, and that's often where the most interesting discoveries come from. If you find this kind of careful look at viral claims useful, consider subscribing. We keep digging into the stories everyone's sharing and checking what the evidence actually says. So what do you think? Do you believe AI will eventually help us truly understand what animals are saying, or do you think there are limits we may never get past? Let us know in the comments. We read them all.